Okay, AP Calculus AB, Unit 6, Day 2 warm-up and lessons on the back. Try the warm-up and try it on your own first. Read the problem, try and draw a picture, create some variables for the things involved. So from the edge of the dock, 12 feet above the surface of the water, a rowboat is being hauled in by a man with a rope. How fast is the length of the rope changing when the boat is 5 feet from the dock? At the same moment, find the rate of change in radians per second of the angle formed by the rope and the water line. So I try and draw a picture, think about what things are constant and what things are changing, create some variables, figure out how to relate those variables. What rates do you have? What rate are you looking for relative to your variables? So try it on your own first and pause the video and try it on your own. And then maybe if you do as much as you can, get stuck, unpause the video, watch it to a point to where you can maybe finish it on your own, pause the video again, try it on your own, because you're going to need to be able to start doing these on your own. Okay, I'm going to go ahead and do it. So there's a dock, and so this is always going to be the first tip. Draw a picture. So I'll draw a picture. So you have a dock. I don't know how much effort you want to put into drawing it. Maybe if you're avoiding doing your math homework, you might make a more beautiful picture. So here's the water. There's the dock. So we have a boat, and so there's a guy on the dock pulling the boat in with the rope. Now it says rowboat's being hauled in by a man at 4 feet per second. So the rowboat's coming in here at 4 feet per second. Okay. When the boat is 5 feet from the dock, but that's changing. How fast is the length of the rope changing? So at the same moment, find the rate of change of the radians of the angle form. So we'll wait to do that one. So we got to create some variables. The main thing I think that we're going to be using here is Pythagorean Theorem. There's a single right triangle. So you might use X, Y, Z. You might use A, B, C, whatever. Now, if we do that, that means that this is d dt right here. And we need to decide if it's positive or negative. And it has to do with being tied to A. Is A getting bigger or smaller? Smaller. Got to make it negative. And then we're going to try and find dc dt. What do you think dc dt should be, positive or negative by the time you're done? Is it getting shorter or longer as the boat's being pulled in? Negative. So you should know right now that it's negative right before you even start. So I think that's good. So now we got to figure out a relationship of how to get C and A together. Now it did say that the dock was 12 feet tall above the water, so we know tides or anything. So the relationship is A squared plus B squared equals C squared, if you use the letters I use. And so then we're going to take the derivative. Next step is, so you find the relationship, then you got to take the derivative with respect to time. This is what we do on every single one of these problems. And you got to do it implicitly, because A, B, and C don't have any time in them. You don't see the T's, but you're taking derivative with respect to time. So it's going to be a 2A, right, to the first power, and then dA dt. That's that chain rule, okay? Implicit differentiation, plus 2b to the first power dB dt equals 2c to the first power dc dt. So we've taken, now the thing you're looking for should show up here. If it doesn't, then you should be worried. The thing they gave you should show up. We have this. So we can start plugging things in. We have A is 5 and dAdt is -4. Now, if you don't put that negative there, it's going to mess up your answer. B is 12. How is B changing? It's not. So the derivative of B is 0. So that whole term is going to drop out. C, we don't have C. So we're going to have to figure out what C is from the Pythagorean theorem. So a lot of times we have to use, so just re-emphasizing why this is negative. A is shrinking. Okay, so it needs to be a negative rate. Okay, this right here, the height is constant. So its derivative, its rate of change is 0. Okay, so we got to find C. So we're going to use a squared plus b squared equals c squared. And so a is 5, b is 12. Okay, so we get 25 plus 144. And that's going to be 169. And you can take square root of both sides, plus or minus. I always want to see plus or minus work. So many people leave it off when they need it. So yeah, even though this time it's going to be positive, I don't care. I want to see plus or minus. Algebraically, plus or minus is correct. Geometrically, we're only going to go with positive. But we're doing algebra before we get there. So we got to plug that in up here for that value. So now we can simplify this. This is 10. That's going to be negative 40 equals 26 dc dt. And divide both sides by 26. We could reduce the answer. Take a 2 out of the top and bottom, negative 20 over 13. We got to put the units. What are the units of C? Well, it's one-dimensional units, and on this problem we have feet, so it's got to be feet. What are the time? Seconds. They told you your rate already. And so it was negative like we expected to. Don't forget the units. Got to have the units, okay? So that's how we could do it. Now I want to give you guys a tip of how to make this problem easier that we're going to try and take advantage of, okay? And I think I may have mentioned this before. If something is constant, means it's not changing. If something's constant, just plug it in at the beginning, like before you even take the derivative. Only if it's constant, okay? Like in this case, b equals 12 is constant. A equals 5 is not constant. So when we have a squared plus b squared equals c squared, I'm going to go ahead and plug 12 squared in right away. Okay? And that's just going to make the work easier no matter what we have to do next. That's the only value you can plug in. I can't plug in the c equals 13. I can't plug in a equals 5. They're changing. So I can't do that before the derivative. But b is staying the same all the time. So now when I take the derivative, 2a dA dt, and then right away the derivative of 144 is 0, and then you get 2c dc dt, it just makes it quicker and easier. We got the same result the other way, but we had to think a little harder. We did extra work. So, that's the big tip. Now, after that, the work would be the same. We'd still have to find c, okay? Now, there's another part of the problem that we have an answer. It says, at the same moment, find the rate of change in radians per second of the angle formed by the rope and the water line. So that's this angle right here, okay? Now, first of all, so that means we're looking for d theta dt, okay? Now, do you expect it to be positive or negative? Is that angle getting smaller or bigger as the boat comes in? Think of it. As the boat comes in, the rope gets steeper and steeper and steeper. That angle gets bigger and bigger and bigger. We expect to get a positive answer. Now, we need a relationship, right? Involving theta and A, B, or C, okay? Now, I'm personally going to want to use the 12 because it's constant, and I'm going to want to use A because it's a nice answer, and I don't want to have to rely on finding C if I don't have to. So in general, I try and use the original information as much as possible because I know it's correct, and it's simple, and it's pretty, and it's easy to work with. Relying on extra work, other answers can be dangerous and just more work. So which basic trig function would involve theta, B, 12, and A? Opposite and adjacent. That's tangent. Now you could do the other ones, but tangent theta equals opposite 12 over A. Now, I'm not going to put the 5 in, but I'm going to put the 12 right now just because of what we talked about, right? Now, you could do sine. You could do sine theta equals opposite over C. But then that means you're going to have to find C. That also means you have to find dc dt, which is kind of ugly. And it means you got to get all those right. I personally wouldn't go with that. You could do cosine equals adjacent over hypotenuse. Again, you're going to have to use C. And yeah, that'll work. You'll use the answers that all that work we did. But let's imagine that you didn't even want to find C or dc dt to begin with. I think this is the best, personally. Now, we got to take the derivative. Now, it's up to you. Do you really want to do chain rule? Because we could treat this as 12a to the negative 1, and that's a super easy power rule. Derivative tangent is secant squared theta d, and then you got to do d theta dt, which hopefully you know you need in your work, equals, I'm going to do it like this, negative 12a to the negative 2 dA dt. That's so much easier than the quotient rule, but go for it. Do the quotient rule if you really want to. Okay, now this is what we want, right? And we have A, we have dA dt from what they originally gave us. We don't have secant theta, so we're going to have to figure that out. So for now, I'm going to leave that blank for a second. Negative 12 over A is 5 squared, and then dA dt was negative 4. Okay. Now we got to figure out what secant squared is. Now what I would do is I'd say, okay, well, secant squared is 1 over cosine squared, right? Co with a non-co. And we're trying to find cosine is adjacent over hypotenuse. We have a right triangle. That's actually where this came from originally. And so this is 1 over. The adjacent side was the A side, 5, and then the hypotenuse was C. So you're going to have to find the hypotenuse anyways, and then it gets squared. So that's what secant squared is. It's 1 over cosine squared, and cosine is adjacent over hypotenuse. And then you got to remember to square it. So d theta dt equals negative or positive 48 over 25. And then this is going to be 25 over 169. So we're going to multiply by 25 over 169. And those cancel each other out. And so we get 48 over 169. Now, it came out positive like we said it should. We have to put the units. For angles, it should always be radians now in calculus, no more degrees. Radians over time is going to be the same time units that we used before, seconds. All right? So it's getting bigger, just like we thought. Make sure the signs of these answers make sense. So that was a little more challenging and added a little more some tips. Now, let's do the problem on the back as just one more helpful thing. Now, the problem on the back has to do with a cone. And there's a lot of cone problems. On the last summer assignment, there was one cone problem, but it's not as tricky. It wasn't as tricky as most cone problems. So there's 3 cone problems on today's assignment. So you really want to see this because this is going to really help you. They kind of have their own strategy. So this one says a liquid is being cleared of sediment by pouring it through a cone-shaped filter. If the height of the cone is 16 inches, the radius of the cone at its base is 4 inches, and the liquid is flowing out of the cone at the tip at 2 cubic inches per minute. Then how fast is the height of the remaining liquid in the cone changing when the cone is half full by volume? So we want to draw a picture. It's an upside down cone, and stuff is pouring into it and coming out the tip. Okay. Now, it says that the cone is 16 inches tall, and at its base, the radius is 4 inches. The base is actually on the top because it's upside down. So, but it has a radius that's changing, and it has a height that's changing also as the problem progresses, and it forms the height is a right angle. So we got to figure out, what do we have? It says the height, as soon as it comes into the liquid is flowing out at 2 cubic inches per minute. That's volume, which should make sense also. It's like amount, 3-dimensional amount of water. and it's cubic inches, that's volume. How fast is the height? So we're looking for dH dt when it is half full by volume, not half full by height. Half full by height would be a lot easier. That'd be at 8 inches height, but half full by volume. So that kind of summarizes the problem right there. So right away, we need a relationship. Now, by the way, this dV/dt, we're going to treat it as negative because we're losing volume. And we also expect to get a negative dH/dt because the height should be decreasing as the fluid goes through the filter. Okay, so what's the relationship? Well, for a cone, the volume of a cone is 1/3 pi r squared h. Now, this introduces a challenge because we have two variables and you don't want it. Okay, in fact, we want all h's. We don't want any r's. We don't have any drdt's. So if you were to just jump into it and start taking the derivative right now, you could do it. dV/dt equals, now you're going to have to do a product rule here. So you got to do 1/3 pi r squared dH dt plus, then you're going to do 1/3 pi h times the square root of r squared is 2r to the first dr dt. So, I mean, that's nasty. And now you still have the issue of you got to figure out what r is and what dr dt is and h and dH dt. I mean, this is what we're looking for. So what I'm going to say is that let's not do that, okay? Because, I mean, we can make it work. On the homework last night, I think the radius or the height was equal to the diameter, so we were able to replace the radius with the height over 2 and get it in one variable. So we really want one variable if possible, okay? So the way we're going to do that, this is special for cones, is that if you draw the radius and the height in, you see two right triangles. So what we get is we get similar triangles. That's how you're going to get r in terms of h or h in terms of r, either way. And for similar triangles, r over h equals the original r, which is 4, over the original h, which is 16. So this is your relationship. The sides of similar triangles are proportional. This always happens in cones. So from here, you could either say r equals 1/4 h, or you could say h equals 4r. If you're to solve for this, flip both sides, you get h equals 4r. Now, which one do we want to use? It depends on the problem. It depends on the information they gave you. Maybe they gave you dRdt. Well, then you want all r's. Maybe they gave you dHdt. You want all h's. Maybe you want dHdt. We want all h's. We want all h's. So we're going to replace the r's with h's this time. So we get our new volume formula. So we haven't done any calculus yet if we ignore that. This is all just prep work that you should do right at the beginning. So r equals 1/4 h. Make sure you put it in parentheses because you got to square the whole thing. So h squared. And then let's simplify it. So volume equals 1 over, that's 16, so 48 pi h cubed. This is our new volume formula that we want to use for this problem. It's going to make the work super easier. It's going to make life way better. So you want to do that first thing before you do any calculus. Get your volume of your cone in all r or all h, depending on what they've given you and what they're asking you to find. Okay? So if you don't do that, guess what? You're going to have to use these similar triangles anyways later to somehow pull this one off. It's better to use it right away. It makes your work way easier. You're not going to get away from the similar triangle idea. You're going to have to use it. If you use it at the beginning, it makes everything very a lot easier. So now if we take the derivative, dV/dt equals pi over 16 h squared dH dt. I mean, that derivative was just way easier. But now there's no r's or h's or anything. So let's see, what do we got? We got -2 for dV/dt. We don't have the height, and we're looking for dH dt. So it feels like we're really close, right? We just need the height. Now it said half full by height. Well, that'd be easy. We plug 8 in because that'd be half the height. But half full by volume is different. There's a lot more volume at the top. How full by volume is going to be an H value that's more than 8 for sure. That's where this problem gets a little trickier. So we should find the full volume first using the same. We can use the original 1/3. I would still use our new formula. I would use the pi over 48 h cubed because we want to get an h, and having r mixed in is just going to make things annoying again. So what's the full volume? Well, that would be when the height equals 16 cubed. Now, before you multiply that 16 out, let's try and simplify this. We could take one of these 16s out, right? And then it'd be 16 times 16 pi over 3. I'm going to leave it like that actually for a second. Okay? Now that's the full volume. The half full volume is going to be half that, so you're going to get 8 times 16 times pi over 3. Right? And then we want to figure out what height goes with this. So we're going to set it back equal to the original volume formula to figure out, well, what's the height that will give you half the volume. Okay? So now we get h cubed equals 8 times 16 pi over 3. I'm into not multiplying these numbers out right away because you're going to have to reduce them later on anyways. Times 48 over pi. So the pi's cancel out. 3 goes into the 16, so we're getting a little closer there. Then we got to take the cube root of both sides. And that's where I would just leave this 8 times 16 times 16 because the cube root of 8 is a 2, right? We can take another 8 out of 16. We can take another 8 out of this 16. And then you have a cube root of a 2 and a 2 left over inside. So that's going to be 8 cube root 4. That's your h. Oh my gosh, that wasn't calculus. That was just a lot of messy geometry and algebra. That's what goes in here. 8 cube root 4. So we're close. I do want to simplify it. The 8, by the way, cancels out with 16 to give you a 2 right away, right? And then the cube root of 4 squared is going to be cube root of 16, right? Which we could take another 8 out of, right? The algebra on this is intense. So when you take the cube root of 8 out, you get another 2, and then cube root of 2. These 2's cancel. We're getting close. We're getting close. So dH dt equals negative 2 divided by pi cube root of 2, which, let me make sure I didn't make any mistakes because I feel like my answer is off. Did I do that right? Let's see. Let me make sure. Oh, shoot. I was supposed to square the 8 to get a 64. So then when I reduced it here, there should be a 4 here. So there should be a 4 here. Okay. So there should be a 4 here. So this is going to be 8 pi cube root of 2. And then we could reduce that a little more. We'll take 2 out of that. So we get dH dt, oh my gosh, finally, negative 1 over 4 pi cube root of 2. The units are h, which would be units to the first power, so inches, over time is seconds. And I'm fine with that. You could rationalize the denominator if you want. You would get a cube root of 2, and then you cube root of 4 to make that a perfect cube, and then you get extra 2 down here. So you could do negative cube root of 4 over 8 pi. That is the rationalized version of it. But wow, that was tough. But the main thing, that was tough for some other reasons, but the main thing on this is to get your volume formula for cones in all R or all H, which we did do on last night's homework, but they kind of just hinted it to us. They told us, the height equals the diameter. So that was a little easier. But you want to get all H before you start any calculus. So here's today's assignment out of the book. Do all the problems, try them all. You need to get practice with these to get better at these. So, okay, try them out. Check your odds in the back of the book. I might put the evens online just for you to check. So see if they're there. That's it.